Welcome to the another video of electric drive. Here we will discuss one numerical on the conveyor belt actually. So conveyor belt is there. So let us assume a conveyor belt. Okay, and this is a conveyor belt of some distance. As the given data, the distance of this conveyor belt is 200 meter or 0.2 kilometer. So that's the distance of this conveyor belt, and behind it or below it there must be some motor is there, and this motor is connected with obviously with a gearbox, with fixed gearbox, and that gearbox must be connected with a motor. So you need to find this motor, what is the specification of this motor, and some parameters may be given to here. Like if this conveyor belt is used to pick the coal from one end to the other end, and the rate at which the coal is getting in is the rate is given as how much ton? 100 tons per hour. This is the rate at which the coal is getting into the conveyor belt, and the velocity of this conveyor belt is fixed. That velocity is equal to 1.2 meter per second. Now if the length is fixed and the velocity is fixed, so at any time what is the time taken for this belt to take the coal from one end to the other end? In that way we can calculate what is the total coal that is being there at any moment. So we can calculate the time from here. So time taken to take the coal from one end to another end, you can find if this is in hour, this is in kilometer, let us say keep it in meter again, 200. This will be like velocity is in 1.2 meter per second, so you will get this value in seconds here. So now you can convert this into hour. If you take 200 by 1.2, if you divide by 60 and then again 60, that is 3600. So you will get this in terms that much hour, right? So you get what is it, hour, time in hours, and if you multiply with the rate with which the coal is getting in, so you can get the weight of the coal. That will around 100 tons per hour. So this much. So let us convert into kg also. So you can have 100 into 1000. 1 ton is 1000 kg. This much per hour. So you just multiply with the time, that is 200 by 1.2 into 3600. So that is the weight of the coal, total coal that is being in. We can calculate. This value will come around 4629.62 kg, right? So you get the mass of that weight of the coal that is being in. So what is it is like what is the weight? A linear motion of the weight is being given, where the weight is 4629.62 kg. That is the thing given to you. Okay, so one can convert that into equivalent inertia. What we can say is equating the kinetic energy in both the sides. We know that J equivalent is equal to mass into velocity by omega m, this whole square. So that value, the mass is given to you, that is 4629.63, and here velocity is already given 1.2 meter per second, and omega m is the speed of the motor is given as 1200 rpm. Yeah, the speed of the motor is 12, and this motor is speed is given to you. So you can convert this 1200 rpm into radian per second. So 2 pi into 1200 divided by 60 will go up here. So this is what the value, and it will come around 0.422 this square, 0.422 kg meter square. So you get the value of the equivalent inertia that is reflected to the motor because of the entire load and this setup. So in this way we get the value of equivalent inertia. Another thing that is important is let us if the J0 value is there, the motor is having its own weight, that is 0.1 kg meter square. So this equivalent inertia and J0 and this equivalent will get add up, right? And we need to find what is the equivalent torque. So equivalent torque that is developed, the load torque that is developed can be written as J0 plus J equivalent over here total into d omega by dt or J d omega by dt. So we can add up this value 0.1 plus 0.422 into d omega by dt. D omega is, what is d omega by dt here? So let us find out. So to get this rate of acceleration d omega by dt, what the given data is that from the speed n is equal to this or the velocity of 0 to velocity of 1.2 meter per second. Okay, or let us not take the velocity over here because we are talking about this inertia, so it's about the motor. So let us say the motor rotate with the initial speed of 0 rpm to the speed of 1200 rpm, that is from 0 to 1200. It takes a time of 8 seconds. If it takes a time of 8 seconds, so in that way if we will check, so we can write whatever the change in the speed omega value. So omega final value minus omega final minus omega initial value is 0 obviously, divided by the 8. The final value is nothing but, this final value is nothing but 2 pi into 1200 by 60. So this will come around to be what? 20, this is 40 pi. So we can write down that as 0.522 into 40 pi divided by 8, and this will come out to be 8.2 Newton meter. Correct? So this is the equivalent load torque that is being reflected to the motor if it drives the motor from 0 to the rated speed of 1200 rpm. So this is a dynamic load that is being affected. So you can calculate what is the value of T equivalent torque that motor would develop to accelerate the belt from standstill to full speed. Okay, so in this way you can find out what is the developed torque. Okay, thank you very much. We will come across some more numericals and concept in the next videos.